Okay, today's lesson is going to talk about relations and functions. So we have a couple of key vocabulary words we have to get straight from the start. And the first one is domain. Now there's a lot of things we're going to call the domain, but really it's what we put into a function. It's the input. We're also going to talk about it being the x values on a graph or the independent variable. Now the range is the output. And if you can guess, this is going to be our y values on a graph or the dependent variable in a situation. So we're going to be talking about the domain and range of pictures, of sets of coordinates, of lines, of curves, of all sorts of things. So we're going to be talking about what can go into them and what will come out of them. So if we're looking at this picture here, we need to create a list of coordinates. And remember, those are our x, y values. And so our coordinates for this point, x first, -4, 0. Our coordinate for this point is -3, +1. Our coordinate for this point is 0, -2. Our coordinate for this point is 1, 2, and our coordinate for this point is +3, +3. Now, coordinate notation is when we're going to separate out the domain and range of this list. So we are going to talk about the domain is equal to, we're going to use set notation. We want the x value. So I'm going to pull this one, this one, this one, this one, and this one. And we always do them least to greatest. So this will give me the domain list like this, -3, 0, 1, and +3. Now the range is going to do exactly the same thing. Same set notation, except this time we're going to list all of the output values from least to greatest. Now this means we might reorder them from what they were in this list. If we think about reordering them, we have -2, 0, 1, 2, and 3. Now mapping is another really useful way to think about how these x and y coordinates fit together and to see some of the relationships. So what we do to map is you make a vertical list of your domains. So we're basically just going to pull it from the coordinate notation in numerical order. We're going to do the same thing for our range. And then we're going to draw arrows that connect -4. It maps to 0. That was its partner up here. -3 maps to 1. That is the coordinate -3, 1, right there. 0 is with -2. Again, I'm using this one up here. 1 maps to 2, and 3 maps to 3. So this is a really nice visual way to see how the domain and the range are related. Now there's a couple of key ideas that we have to talk about, and they all hinge about being a function. So we have two situations that are functions. We can have a one-to-one function in which there is a unique relationship between domain and range. There's no repeats, no doubling up. Everybody has its own partner. There are no overlapping situations. That's where mapping is really nice. Still a function, not one-to-one, is different domain values share range values. Okay, so for example, 4, and 5, and -1 also maps to 5. Still a function, not one-to-one. Where things are not a function is when you have the same domain values to different range values. So you can't control. If I put -3 into this situation, I don't know if 0 is going to come out, or I don't know if 6 is going to come out as an output. And that means it's not a function. Over here, if I put -1 in, I'm sure, without a doubt, that 5 is going to come out of that function. There's no doubt. And that's the difference between a function or not a function. And it all hinges on the domain. The domain is the decider. That's where you can't have the overlapping outputs. You can't have two outputs from the same domain. Now, why do we care about this? And are we going to have to map all of these all the time? And the answer is no. And it's the vertical line test, which is a great idea. If no vertical line, remember that's up and down, intersects a graph in more than one point, it is a function. So I can go in here and I can draw vertical lines wherever I want. And they're only going to ever intersect my graph in one spot. If I go in to draw it at any point on the graph and it intersects in more than one spot, it is not a function. So if you have a map, you can tell very quickly if it's a function. If you have a graph, you can tell very quickly if it is a function. Now, let's try some vertical line test examples. So if I give you a line like this, no matter where I draw that vertical line, this will pass. This is a function. If I come in and I do some sort of ugly graph like that, I can still come in and I can draw vertical lines that never intersect in more than one place. So this is a function. If I come in and I draw some sort of a graph like that, there are spots where they intersect in two locations. This is not a function. But it's not just all curves, because some curves will pass the vertical line test. You see, if I come in here, wherever I draw vertical lines, I still only intersect in one spot, so that is a function. If you remember, we also have things called step functions, and they're cool graphs that look something like this. Move it not including, move it not including. And when I come in and think about the vertical line test, here I'm good, here I'm good. But what happens if I draw it right there? Remember that open circle means up to but not including. So this is technically only intersecting in one spot. So this is a function. But if I were to draw my step function something like this, I think you can see what's going to happen when I do that vertical line test. When I do it right here, I'm good. When I do it right here, because these are both solid points up to and including, it's intersecting in more than one, and that makes this